Hello students. So today we are going to learn about rectifiers, and today half wave rectifier is going to be done. So here we have a circuit for the half wave rectifier where one voltage source is given, one diode is there in series with the voltage source, and one load resistance is there. You are going to take your output voltage across this load resistance RL. The input waveform is given something like the sinusoidal waveform. The output we should get, it will be something like this, and the current is this. How this work? During the positive half cycle, diode is in forward bias, so it acts as a closed switch and all the voltage will drop across the RL. During the negative half cycle, diode is in reverse bias and it will act as the open switch. All voltage will drop across the diode and no voltage drop will across the RL. What does it mean? That during the positive half cycle, all the voltage drops across the RL, and that's why we are going to have the positive half cycle in the output voltage. During the negative half cycle, our diode becomes the reverse bias and no voltage drops. All the voltage drops across the diode and no voltage drop across this load resistance, and that's why there is no voltage across this load resistance. Again, during the positive half cycle, diode will be in forward bias and all the voltage will drop across this load resistance, and you will see the half wave output. Let the input supply voltage is V is equals to Vm sin theta, where Vm is maximum value of supply voltage, V is RMS value of supply voltage, and this RMS value of supply voltage, we are going to find out the RMS value of output voltage also, but this value, this Vm by root 2 is only for the supply voltage. Im is the maximum value of load current, VDC is average DC voltage across the load, IDC is average DC current through the load, IRMS is the RMS current through the load. Now to find the DC voltage, VDC will be 1 upon 2 pi integration 0 to 2 pi V d theta, because our output is from 0 to 2 pi, 0 to 2 pi, where we are getting only 0 to pi output, and from pi to 2 pi the output voltage is 0. So to find out the value of DC voltage, we are going to take the half cycle in which we have the load voltage as well as the load voltage is 0. So VDC is equals to 1 upon 2 pi integration 1 upon 2 pi integration from 0 to pi we have Vm sin theta d theta, plus from pi to 2 pi our output voltage is 0. 1 upon 2 pi Vm is common, and the integration of sin theta is minus cos theta. The limits are put as 0 to pi plus, that is 0. So the integration of cos theta minus cos theta, and by putting this limit you will get 1 plus 1. Vm is constant which will come out of the integration and divided by 2m. This will result in VDC is equals to Vm upon pi. The value of IDC is VDC divided by RL. Mind well, when this value is having the forward diode resistance, you will have to add forward diode resistance RF with this RL also. IDC will be Vm by pi into RL. To find out the RMS value, Vrms square is equals to 1 upon 2 pi integration from 0 to 2 pi V square d theta. That is equals to 1 upon 2 pi integration 0 to 2 pi Vm square sin square theta. So the Vm square is common. So Vm square divided by 2 pi, 0 to 2 pi. The equation of sin square theta is also 1 minus cos 2 theta divided by 2. The limits you will put in d theta. Vm square divided by 2 pi. The integration of 1 is theta, and 2 is the constant, minus cos 2 theta is sin 2 theta divided by 2. So it will result in sin 2 theta divided by 4 from 0 to pi, and the value from pi to 2 pi will be 0. This will result in Vm square upon 4. So Vrms will be Vm by 2. Now see, the supply voltage RMS value was Vm by root 2, but we are getting the output voltage, RMS output voltage, to be Vm by 2. Same way for IRMS, RMS current is equals to Vrms divided by RL, that is equals to Vm upon 2 RL from the equation given here. It is also equals to IRMS is equals to Im by 2. The next point is form factor. Form factor is RMS value divided by average value. Now we have found out the RMS value to be Vm by 2. We have found the average value to be Vm upon pi, and this will result in pi by 2. So the value of form factor for the half wave rectifier will result in 1.57. Peak factor. Peak factor is the peak value divided by RMS value. The value of peak is Vm and the RMS value is Vm by 2. So the peak factor for the half wave rectifier will be 2. Output frequency. Output frequency will be same as the F in, because as this is the case, your full cycle will be half wave plus zero no load voltage plus full load voltage. So the output frequency will be same as in F in. Rectification efficiency. This efficiency is defined as DC power delivered divided by AC input from the transformer. So this is PDC divided by PAC. This value is equals to IDC square RL divided by IRMS square RL. So value of eta efficiency is Im by pi whole square into RL divided by Im by 2 whole square divided by RL. This will result in 1 upon pi square into 4, that is equals to 4 upon pi square, 0.4056. In terms of percentage, as the efficiency is always indicated in percentage form, eta is equals to 40.56%. The next terminology is ripple factor, and it is indicated by gamma. It is AC value divided by DC value. So AC value, you can say that it is the AC value delivered to the load, that is I RMS squared minus I DC square, that is divided by IDC. So by putting this thing IDC is equals to inside this square root, you will get IRMS divided by IDC whole square minus 1. But we know that IRMS by IDC is KF, that is form factor, and minus 1. But the form factor we have found, that is 0.57, that is whole square minus 1, and the ripple factor we'll get is 1.21. Transformer utilization factor, TUF, power delivered to the load divided by AC rating of the transformer. So power delivered to the load is PDC divided by AC rated is given here. That is equals to IDC square into RL divided by VS RMS. Now this is the supply voltage, right? Because transformer is your supply. So here we are going to take VS RMS into IRMS. So IDC is equals to Im by pi whole square into RL divided by VS RMS, that is V maximum divided by root 2 into Im by 2. That is equals to Im square into RL into 2 root 2, because this root 2 and this 2 will go inside this numerator part, and this and VSM is equals to Im into RL, and Im is as it is, right? This pi square is written over here. This will result in 2 root 2 divided by pi square, and TUF you will get it is 0.286. That is a homework for you to find out the regulation. Just find out what is the definition of the regulation and find the value of regulation as per your homework.